Now that we have added a base map and we have our shorelines, we're now going to create a digital elevation model of this area. Well, it's already been created for us, but now we're going to bring it in ArcGIS and use it so that way we can run spatial analyst tools on the DEM, our digital elevation model. So you can go online and type in Seattle DEM, and clicking the first link here, gis.ess.washington.edu, we will be taken here to where we can then download digital elevation models for different areas, as you can see here. And so I got the Seattle North as well as the Edmonds East DEM file that we'll be using, joining together and then clipping around the Thornton Creek watershed because it contains both of those areas. So I'm going to drag those in. You'll see one will be Q1022 and the other one's Q1122. So I'm just going to drag those over. So as you can see coming in, they offer a nice grayish tone to kind of showcase the different elevations. But one of the problems is that if we wanted to try to represent them similarly, they wouldn't align properly because the data is different. So the first step we need to do is we need to join these two layers into one. And to do this, and for all these next tools, we'll be using Art Catalog. So first, we're going to go to Data Management Tools, jump to Raster, and then Raster Processing. Actually, we're going to actually go to Raster Dataset. So Data Management Tools, Raster, to then Raster Dataset. Then in here, we're going to choose Mosaic to New Raster. Just going to double click this, and this dialog box will open. We then will choose our two rasters, the two DEM files. We now want to choose the folder where these will be saved. And so for us, I want to just save it in my GIS data folder. So I'm just going to go back. I'm just going to click here to go level 1, level up, make sure that that name's here, and I'm just going to click add. So you're not actually clicking the file, you're just clicking the folder. And here I'm going to give it a name and just call it dem_join. We're then going to actually convert this to 16-bit unassigned. And then down here, number of bands, we're going to pick 1. And that's because when you open up the properties tools here, number of bands is 1. And actually, pixel depth is 32-bit. So we could actually go to 32-bit for our pixel type. Actually, it doesn't like that. So we'll just go back to the 16-bit unassigned. We have our band as 1. So to find out that information, you click on the DEM and then go to Properties. Hit OK. And now once that's completed, we're left with a single file, a single DEM, which is really nice. So now we can come in here and we can change this to this color band or this kind of gradient, hit OK. And this gradient is actually designed to try to show the different elevations from kind of the greener areas being closer to the water to the browner up all the way to the white areas where they at larger scales could represent snow. So now that we have this, we're now going to want to clip it to our watershed scale. So that way we can start doing our analysis only to the watershed. So we can get a really detailed look at the watershed from the DEM. So to do this, we're actually going to use search. So I'm just going to type in clip in the search bar. And we're going to look for clip geoprocessing. Or actually, we're going to the clip data management, because here a subset of a raster. So we're going to click this. So once we double click, actually that was right, the clip data management. We're going to choose the DEM to join for the input raster, our output extent. We're going to want to do our Thornton Creek watershed feature. And make sure you click this because you want to use the input feature for clipping geometry. So click here to make sure that's clicked. And then we're going to save it to our GIS, where our GIS data is being saved. So I'm just going to double click here. Call it DEM watershed. Then click save. And click OK. So now what we're left with is just a DEM of our watershed. So once again, we can change our color ramp, hit OK, to get a better sense of the high points and then the low points within our watershed, as well as where all the valleys are and potential areas where there could be water.